notice it. And if you're a trained ear, you'll be able to say, wow, that's like nothing I've ever heard before, because when you do hear it, it's like the entire way the song sounds changes, and not in a way that's easily describable, because it's actually what's called a texture change. And that's something closer to detail and less soundstage. So here's the inside of your in-ear monitors that if you use earbuds or in-ear monitors that actually go inside of your ear canals. This is what they look like broken down. So this one that's here actually has one driver. These are crazy magic calculation and math. The people who make these are probably masochists, and I give them a lot of credit. It's a whole lot of taking a driver that fits in the enclosure, maybe even you build it around a driver that you really like. For example, the GR07s, which are the ones with the blue tips down there, use a biocellulose driver, which is a driver that, to my knowledge, is grown and then harvested, which is pretty crazy. And when you manufacture it, it's made of what is biocellulose, and I won't pretend to know anything about biology, I'll leave that to you. But what it actually does is it allows it to be a super thin and super light membrane, just like the electrostatic stuff I was talking about earlier. And the thing about those tiny drivers is that not only does one of them have to create the entire sound spectrum a lot of the time, but it has to do it and sound good, and sound hopefully consistent, where the treble doesn't sound crazy and the bass is like not even there, and you want some sort of balance. So they get that by using chambers and using filters, which are essentially pieces of fabric or other materials that are put in front of the speaker and put in front of your ear. So you can see here, these are canal dampers. These are going to take some of that really harsh treble sound that a tiny driver will be able to squeak into your ear and hopefully filter some of it out. This one here is a larger damper that's going to probably do a lot of the same thing. Back here you can see that there's a sub-chamber. That's actually a pocket of air that's used to keep the driver from flopping all over the place when it's time to make those really big low notes. And you can see that they use the word optimized a lot, and that's because you bet your ass they're making these, testing them, being like, oh my god, it's so harsh, what do I do? And then putting another filter on. You can bet that just like with these other headphones, they're taking 20, 30, 40 materials in some of these big manufacturers and just putting them over it until one of them sounds right. I think I've hit everything. Oh, okay, so usually the big trade-off with in-ear monitors as opposed to over-ear headphones is that you're going to lack soundstage. If you thought that closed headphones were narrow, these are way narrower. They're literally in your ear. You hear it exactly between your ears, right in your head, and that's it. If you can find a headphone that's in your ear and sounds like a speaker or sounds like a set of even closed over-ear headphones, it's magic, it's crazy, and that's just the result of some person's slave labor. They slaved over these earbuds because that is an amazing thing to be able to do, is to take a soundstage out away from where the driver actually is, especially in a closed setting and in such a demanding and small setting like this. One last thing I want to mention, other than the fact that my phone is making buzzing noises with the unprotected speaker, is that your earbuds versus in-ear monitors. The difference being that the in-ear monitors are, no matter how inexpensive they are, in-ear monitors sounds like some elitist term, and it basically is. Earbud will sit in your ear, and your in-ear monitor will actually go into your canal. Always want to go into your canal. A lot of people don't like it. I know my father, for one, will not put anything in his ear canal. But you gain so much because the seal is so important. They calculate these drivers to be one way, where they have a very fixed and very fragile pressure system going on inside of them. And when you screw that up by having a bad seal or trying to take a headphone and make it this small without being able to just use pressure tricks and have to have an unpressurized cavern essentially that is your ear, you're gonna end up losing sound quality, specifically soundstage and separation. You're not gonna be able to have it because it keeps them from being able to do those things like this sub-chamber where they can measure the pressure on both sides of the driver and understand how it's going to react. Because it's just open air on one side and you have a lot less control over it. One more thing I want to touch on here is that IEMs can have anywhere between like 1 and I think like 6 is probably the most I've ever seen drivers, and still be really small. So down there we have IEMs that are 1 driver and 2 drivers. So next is amplification. We're not going to spend nearly as much time on this as we did with speakers. Down here we have 3 different amps. This one is an amp DAC, which we're going to talk about a little bit later, what a DAC is and what it necessarily does. This is a headphone amplifier that is almost identical to the one that's in here, it's just slightly bigger. The same lab manufactures both of these, and that's called JES Labs. They're like a pretty well-known manufacturer, and what they make is usually very high quality. And then this one is a separate one made by a company called Shit, and they're known for value, slight warmth, and really nice, really high-end products at a price that is reachable to the average consumer. Their highest-end products being like $3,000, but their lowest-end products being like $100. So they give you a really good range, and if you wanted, you could go entry level with Shit's basic stuff, and then go all the way up to their highest quality shit. So let's see. The amplifier that I have up here is actually a speaker amplifier. It happens to be the one I use just because I really like it. And you've got some crazy big inside doohickeys that I won't pretend to tell you what they do. What I will tell you is that the one you're looking at here is a class, I believe, T amplifier, and that's just a trademark made by a company called TriPath. You can see why they would want class T. On a class D amplifier that's modified. So that's your traditional amplifier that you turn it up and it uses more power. And it's basically super efficient because it's not wasting power. But class A, on the other hand, which is what the bigger one under, so the silver big box right there, that's the Astar 2 from Shit as well. And it says class A, and it's single-ended, transformerless. So it means there's no transformer. I don't necessarily know what that means because I'm not an electrical engineer. But what I do know is it gets super hot because it's always running at the maximum output and then dialing it down based off of how you have the volume up. So it's the opposite of actually turning the amplifier up to achieve a higher sound. You're actually turning it down more and more as you need it softer. Things that class A's have problems with, it's warmer sound. It tends to color it on the warmer side, which means the bass comes up a little bit and the drum comes down a little bit. And it has issues with dynamic range where the highest octave and the lowest octave will actually kind of get screwed up sometimes. You can't quite get it out of them unless it's a really high quality one. So that one actually does have a slight problem, and I highly doubt 90-something% of people can hear it, but when you listen to it for hundreds of hours, you eventually you can hear a little bit when compared to specifically the objective DAC in the center. Which is known for being like mathematically perfect, and like no matter what you do, you can't get better than it because it doesn't matter how good the components are. You know, it uses crazy mathematical calculations which you can all read online. It's actually open source hardware, or it's open source hardware, but it's Creative Commons licensed, so you have to keep it like if you want to distribute it under that name, you have to like keep everything in it. Modify. It's some crazy license where, like for example, in here, it's actually meant to be portable. So you can see, this is one of the earlier models, you can see that the power cable is on the front. And even though, why would you ever want that? Well, it's because the power cable basically connects to 9-volt batteries, terminals. Because they have to put 9-volt battery terminals in it because of the way the license works out. And the guy who made it, did all the calculations, he figured out the face of the earth, nobody knows where he is. His name was the Northwest Audio guy, and everyone will either say he's the god, or they'll say he's the dick, or they'll say he's both. So you can hear differences between these two amps by actually taking an AV switch, which is something like this overpriced American-made switch. American-made, it's worth the $30 I paid for it. It does have a switch. Just pass this around. It's just so nice. I don't even care if I have to hear the clicking while I'm talking. It's worth it. It's a nice click. It's very satisfying. And basically what that does is it actually will let you plug in either two sources to one headphones, which is like the thing it's best used for, so you don't have to take the headphones off your head, or one source and two headphones where all you have to do is just switch the headphones and hit the switch, and you can quickly compare the two sets. Let's see. That's the one I have down there, and it's the one you'll hopefully get a chance to listen to after this. It's ASCAR 2, like I said, Class A. It gets super hot to the point where the ones on the, I don't know what's going on inside there. A little piece of plastic or something. Really? Alex is calling me. Do we want to answer? No. I think he's probably having trouble getting into the building, so if somebody wants to go out there, that'd be good. He probably forgot that it was at 9.
I'll use the last semester time.
He may or may not be there. Who knows? Okay, so it gets super hot to the point where it literally melted the feet that I put on it. Like the adhesive kind of just like heats back up and like goes wherever it wants. Hey. So after all that stuff that I talked about, that's all solid state amplification. That means there's no moving parts and there's no vacuum tubes, which, like in the picture you're seeing here, can be used for amplification, was in the past used for amplification, but is usually no longer used simply because it's considered to be inefficient and not very accurate. And when you hear a tube amplifier, which to be honest, I think I've maybe heard one in my life, it wasn't anything super drastic, but when you have one like this with like 4 tubes, it's actually going to make it sound very different. It's going to texture it with a phono sound, which basically means it sounds like any old equipment you've ever heard is going to sound. And it's going to make it sound like the sound stage is warped, and the sound signature is usually going to be significantly warmer. To the point where if you heard something here before, it's going to like move like back here. And it'll bring the entire sound stage either back or forwards or however the tubes are going to change it. And that changes based off of the tubes you use. And these tubes work on a very basic level. Again, I'm not an electrical engineer. With a cathode and an anode. And the cathode is slightly positively charged, the anode is very positively charged. And in between them is what's called a grid, and the grid is used to actually transport the signal into the vacuum sealed tube. So that's your music. The cathode sends electrons through the grid and over into the anode, which then transports them back down at a higher amplitude than it was previously.